This section is about using right triangle trig to solve problems in the real world. You're going to use angle of elevation and angle of depression in these problems. Um, the thing to keep in mind when you're looking at angle of elevation or angle of depression is when you're looking at angle of elevation, you're looking up at an object, and when you're doing angle of depression, you're looking down at an object. And really, when you're drawing your triangle, the horizontal will be on the bottom when you're looking up at an object, and it'll be along the top of the triangle when you're looking down at an object. But if you have to figure out the horizontal distance, it wouldn't change even if you're measuring that distance along the ground or up in the air. It's just where you would draw it in your right triangle. So for angle of depression, the horizontal is on the top of the triangle. For angle of elevation, it's on the bottom of the triangle. All right, so I have a angle of elevation from a buoy to the top of a lighthouse, 130 feet above the surface of the water is 5 degrees. Find the distance from the base of the lighthouse to the buoy. So here's the buoy. There's the lighthouse, and the lighthouse is 130 feet above the surface of the water. And if I draw the triangle, it's an angle of elevation, so the horizontal is going to go along the bottom of the triangle. And the angle of elevation is 5 degrees. So I want to figure out the distance from the buoy to the base of the lighthouse. Looking at where the angle is, I know that the opposite is 130, and I'm interested in the adjacent. So knowing that, I'm going to use tangent of, and because it's opposite over adjacent, it's going to be 130 feet over x feet. We always put an angle inside of sine, cosine, and tangent. The angle should always be inside here. It's not just tangent, it's tangent of an angle. That angle in this case is 5 degrees. If I were solving for x, I would then multiply both sides of this equation by x so that the x could be on the top. So it's x feet times tangent of 5 degrees equals 130 feet. And then I'm going to divide by tangent of 5 degrees. So tangent of 5 degrees doesn't really have units. So both sides of my equation will be in feet. Now it's very important that we make sure our calculator is registering degrees when we use tangent. I'm going to check my mode, and my calculator right now is in radians, so I'm going to change it to degrees. And then I already forgot what numbers I'm using. I'm using 5 degrees, I know that, and 130. So I'm doing 130 divided by tangent of 5 degrees. And I get 1,485.9. Now, I want to emphasize that this triangle is not drawn accurately because this is a lot more than 5 degrees. So since 5 degrees is a very small angle, it kind of makes sense that this would be a lot bigger. Keeping in mind that this angle would then be 85 degrees. So the side opposite that angle is going to be much larger than 130 feet. Okay, the next example, I have a 36-foot wire. So my wire is 36 feet long. It stretches from the top of a vertical pole to a point on level ground 24 feet from the base of the pole. So we have 24 feet. find the angle of elevation that the angle makes with the ground. So we're trying to find this angle. And if we want to find that angle, we have information about the side that is adjacent and the hypotenuse. So we want to use the one that uses adjacent and hypotenuse. That's cosine. So we're going to do cosine of theta, but we don't know theta. And then we're going to do adjacent over hypotenuse. These are both in feet, but the feet are going to cancel. And in order to get rid of cosine or blow up the cosine house, we're going to do cosine inverse. And we're going to let our calculator answer that question in degrees because we're interested in a real world problem, and usually that involves degrees. So we're going to do cosine inverse of 24 divided by 36. And we get 48.2 degrees. And then the next question says, how tall is the pole? So we're trying to find this missing side length. One thing we could do is we could use Pythagorean theorem. We could do a squared plus b squared equals c squared. And so b squared equals 36 squared minus 24 squared. And then we could take the square root of that. Another thing we could do is we could use our angle, and we could say sine of 48.2 degrees would be b over 36 feet. And that would be another way we could find that length. When you know three things about a triangle, you have some flexibility. I'm going to go ahead and use Pythagorean theorem because that doesn't involve any numbers that I found. It just involves numbers that I was given. But I wouldn't take points off if you used a different method. So I get 720. I'm going to take the square root of 720, and I get 26.8 feet. Really, the hard part of these problems is drawing the picture and understanding where things are. Because this was an angle of elevation, my horizontal was going to be along the ground. Now this is an angle of elevation problem, angle of depression problem. I have a person who's 5 feet tall standing on top of a 115-foot lookout tower. So I'm going to say that that makes 120 feet for my tower. I look down at my friend on the ground with an angle of depression of 32. Now keep in mind that the horizontal has to be up here because I'm doing an angle of depression. So this is going to be 32 degrees. And this side length of the triangle is 115 because, 120, sorry, because that's how tall it was on the other side. So it's not going to be any different here. So this vertical and this vertical would match. And when the friend starts walking, it's going to be the same as this distance here. Okay, I don't know why it looks like I wrote 321. I'm going to erase that extra line. Okay, so then I'm going to use my trigonometry. I know the opposite length and I want to know the adjacent length, so I'm going to use tangent. So I'll do tangent of 32. And remember, when you do sine, cosine, or tangent, the next thing should be an angle, equals 120 over x. I'm going to blow up the tangent house by doing tangent inverse. Oh, no, I'm not. I don't know. I don't have x inside of the house. I apologize. I'm not going to do that. I'm going to multiply by x. So I have x times tangent of 32 equals 120. And then I'm going to divide by tangent of 32. And keeping in mind that I'm in degrees, so I want to make sure that I do this with degrees, I'm going to do 120 divided by tangent of 32. And that gives me 192 feet. I know that that distance seems like it's way up in the air, but it's the same as the distance that our friend has to walk. Okay, so when we're doing angle of depression, the horizontal is along the top. When we're doing angle of elevation, the horizontal is going to be along the bottom. All right, and good luck with these problems. Thank you so much. Bye.